Yeah, hello everybody. New situation in the world. This will, of course, also have a macroeconomic impact. What has happened in the United States, and of course, what has happened in Germany, so to speak. Interesting times. Yeah, in the end, I think the reason why the coalition in Germany bursted was due to one of our aims we have discussed in the end, the debt break in Germany. So the question about how high should be the fiscal deficit, how much debt should we have? This was in the end the reason. So a direct topic we have talked about in this lecture. Okay, then another formal question. Um, about the exam within this course. So we will do it via a little term paper in January. I think then in the week when the exam was planned, I look it up. So, but the tasks you will do then, or you will have to do then, they will be quite similar compared to my former exams I've posted the former semesters. But of course, since it is a term paper, everybody of you has to solve individual tasks, but every individual task will be similar to the former ones. And I will also give everybody of you one country in the world where you then should look up some data and calculating some average growth rate and some performance of this country. But how you do this, I will do an example with you then in December together so that you somehow know what you should do then. And the time will last then that I will give you the task on Monday and that you should hand in your solutions then on Friday so that you have 5 times time to look up the data, do the calculation, and then upload everything in the Moodle course. Okay, but in more detail, I give you the framework then in December. So then we are at the very interesting topic in our course of money. And yeah, here we had also our invited talk in December when Dirk Gerlach will talk about monetary policy and money and interests and prices. And I think today also we will come to monetary policy. Okay, so last time we, so to speak, introduced money because money is the central good of exchange and therefore we could use every good with these specific properties in order to use it as money. And during history, well, in almost every society in the world, there was this little blinking metal, which was in the beginning used for money that then in times of developing the economies, then we needed more and more and more money. And for this, there was not enough gold. And therefore, then we invented other forms. And about these forms, we will talk about today. Well, so these were the properties. And well, why we do have these properties? Because of the functions of money. And there we have more or less three functions. In general, maybe the most important medium of exchange, but also to store value over time, and of course to do in a in a modern economy in general the valuation, so as a unit of account. And related to these functions, we have then the motives of holding money, and these motives and the derived money demand function from this we later on will also use, we will use in our theoretical models. So we discussed that in general from the transaction motive and from the precautionary motive we could derive that in general we assume that from these two, money demand will positively depend on income, and from the speculative motive or from the classical opportunity cost argumentation, from these two we can derive then that money demand is negatively dependent on interest rates. And so overall, we obtained then a general money demand function depending on these two variables, income positive and interest rates negative. Well, and then if we are talking about these interest rates, so you can think about yourself. You inherited maybe €1,000 and then you don't know what you should do with it, not directly spending. So you go to your private bank and ask how much interest do you pay if I give you for the next 2 or 3 years these €1,000. Well, and then of course, the higher the interest rate you will think of, the better it is you get. But on the other way around, what in the end matters, if you give away €1,000, is not only the interest rate you get then, let's say 5%, then after 1 year you would get €1,050. But keep in mind, during this time, there could have happened something. And what could have happened is that over the next years, also prices could increase. Well, and therefore, if you are comparing your €1,000 today with €1,050 next year, in what you are really interested is how much real goods I can buy today with €1,000 compared to €1,050 in 1 year. But also I have to keep in mind that during these times, possibly price level has risen. So it could be the case that if prices has risen more than the 5% interest rate, then I could even with more money buy less goods in the future. And therefore, I have also to ask myself, what is the key parameter I'm interested And this is in direct relation when we talked about economic growth, where we have introduced GDP, gross domestic product, price times quantity. Then we ask ourselves, are we really interested in the growth of these parameter, price times quantity? And then we argued, no, because if only the price level in my economy has risen and the quantity stayed the same or has even decreased, then I would not value that this is a good economic performance. And the same we will do today with the interest rates, so that we are talking about the relation between the so-called nominal interest rates you get from your private bank when you make a deposit and the relation to the price level development. And yeah, this relation between inflation and nominal interest rates, where we then obtain the so-called real interest rates, is called Fisher relation. And this comes from also a famous economist in the beginning of the 20th century, because he dealt very much with interest rates, with government debt, and so on, and the dependence with inflation. And yeah, let's do it with some little example I already introduced. So let's say that we have an amount of K equals 1,000 euros and interest rate I equals 5%. Then after 1 year, I can say we have, let's say this is K0, then K1 equals 1,000 euros times 1 plus 5% equals 1,050 euros. And then suppose inflation pi should be 3%. And then we pose the question, if inflation is 3%, how much is the value of 1,050 euros in 1 year today? So I know that in the future I have 1,050 euros, but since I know that during this time prices has also risen, I want to compare this number with my today 1,000 euros. Is it more? Is it less? How much is it more? How much is it less? And therefore, I make these thought experiment. I have in the future 1,050 euros, but I also know or I expect that inflation will be 3%. And then I go back in time to today and ask myself, what would be this value of 1,050 euros today? And hopefully in your other introductory courses, you have also talked about this thought experiment and the concept which is behind this. And how do you call this concept? What are we doing now if we taking some capital in the future and recalculating it to the value today? Yes? Yes, great. So this is nothing else. Compare this with the concept of present value. There you are doing nothing else. You have an investment. Let's say you are investing today 100,000 euros. First period you obtain 50,000 euros and second period you obtain 60,000 euros. And then you ask yourself, should I invest? And in the first shot, you would say, okay, I'm investing 100,000 and I'm getting out within 2 years 50 and 60, so 110,000. So it is more. So at the first shot, I would say, well, I get out more, so I'm doing it. But then you are doing again, or you are using again the concept of opportunity costs, because you ask yourself, well, of course, I could do this specific investment, 100,000 euros, getting out first year 50, second year 60, but I could also take my 100,000 euros, go to the capital market, then I see the general interest rate for 1 year, and then I say, okay, I could also take my 100,000 euros with, let's say, 5%, and then I compare what is then the outcome in 2 years, or I can do it the other way around. I can ask myself 50,000 euros, the first payoff in the first period. How much do I have to invest today to get in the second year, in the first year, 50,000 euros? And then you calculate this back, and therefore you calculate 50,000 over 1 plus interest rate. And for the second period, you take 60,000, and then because of two periods, over 1 plus interest rate squared. Well, and what we are doing here is nothing else, but only we interchange interest rates with our inflation. So then the outcome is 1,050 euros over 1 plus 3%. This is the value, oops, here. What is the value of 1,050 euros in real terms today if inflation is 3%? Well, and now we could then say the number there equals 1,000 euros, the investment today, times then the real interest rate. So this is then the real interest rate. And if we write this in another way, then we obtain here 1,000 times 1 plus 5% over 1 plus 3% equals 1,000 1 plus real interest rate. This cancels out. And then let's just calculate it. Oops. Directly. So what do we have? This is 1 plus 0.05 over 1 plus 0.03. 1.19, 1.019. This is 1.019. And then we have that real interest rate is 1.9%. Well, or since this is nominal interest rate, this is inflation, we obtain in parameters this relation here. And well, mostly if you look in many books then, or in a direct calculation, we just say real interest rates would be the difference between nominal interest rates and inflation. But this is the analytically right formula. This looks a little bit different. And again, also compared when I talked about growth rates, and there I said to you that you are not analytically allowed to just average growth rates via taking the arithmetic mean, but you have to take the geometric mean of the growth factors. We have here more or less the same case because, of course, interest rates and inflation are nothing else than growth factors. The one is the growth factor of capital, the other one is the growth factor, the growth rate of price level. But why is it possible to say that if my parameters are less than 10%, that then I can roughly use this approximation? For this, we can rewrite this multiplying both sides with 1 plus the inflation rate. Then you obtain 1 plus r times 1 plus pi equals 1 plus I. This we multiply, then we obtain 1 plus r plus pi plus r plus pi equals 1 plus I. The one is canceling. And then we can look at this number here if we are assume that both numbers are less than 10%. Then you are multiplying a small number less than 10%. So less than 0.1 with another number less than 0.1. And in your head, if you're multiplying 0.1 times 0.1, you get out 0.01. So you're moving in behind the digits. So you can say roughly if both numbers are less than 10%, then your error you are doing is in the second, third, or fourth digit you are calculating. But please be careful, especially if you are investing in emerging markets or somewhere else, then you quite very often have in these countries inflation rates or interest rates larger than 10%. Okay, and therefore approximately we can leave out this number. So we can leave out this number approximately if I pi are smaller than 10%. Well, and quite often, if you look up the Fisher relation, then you find also this relation because, of course, it is always a tool if you are making an investment decision and therefore you are not interested what has happened in history, but what will happen in the future, and therefore you use quite often not the historical inflation rate, but expected inflation rate. Okay, and in general, you should compare, oops, compare in general the Fisher relation with the difference of real and nominal GDP growth, because this is, yeah, qualitatively the same what we are doing here, going from nominal interest rates to real interest rates. Okay, so now we have introduced money and the interest rates, and when we go on, I want to talk with you about, yeah, what is, so to speak, money today, because of course we still have our cash money, but we are not paying anymore with gold or silver. And also, when we had this aim of the external balance, we also changed in the world in the midst of the 1970s in general. What is money? Because until this time, we really said we had as an anchor of our money system, in the end, gold. So when we had this system of Bretton Woods or the gold standard in the beginning of the industrialization, then we said, okay, you have your cash money, and with your cash money, you have the right to exchange this with a fixed exchange rate into dollar, and with the US dollar, you have the right to exchange this into gold. But then this system broke down, and what we have then today is just more or less that we promising ourselves that do I have still 5 euros here? These 5 euros have really a value. So that this has a value depends in modern times now in the stability of our countries, so in the stability of our society itself. And well, if this stability is in question, then you see quite often that the currencies in these countries will really have a problem in the value of their money. And for example, if you go right now to Turkey, then you see there that you have there very high inflation rates, and therefore the Turkish lira has a general problem in order to use it as, for example, storing your value, because if you have 50 or 100% inflation, then of course, take the Fisher relation, the money tomorrow is much less worth than today. So, and therefore, because we have not anymore something like this anchor of gold in behind, we talk about money today as, so to speak, fiat money. And fiat, this is Latin, and Latin, this little word just means there will be money. So we just inventing this. So this, there will be money. Oops. And this we should always keep in mind when we are talking about an economy and of course also about our society. So, and now we want to count our money. So what is then money? And if we go back, everything is money. A good which has, oops, where is it? These properties. Then of course money is not only cash money. And think of yourself. I think also most of you are paying only a small amount of your goods still with cash money. And therefore, if we are counting really money, we have to go further. And so we start then with cash money. But since this is compared to the other forms of money, much less, it is even not anymore defined by the European Central Bank. If you are going to their website, they start with the so-called money aggregate M1. Well, and what are you taking then together? This is cash money, so the currency in circulation, and your overnight deposit you have. So this is just your banking card, your credit card, what you have, because with this you are mostly always mostly paying your goods. So overnight deposits. But then you can think of, well, I want to use it, this money, I want to use money as a medium of exchange, and therefore think you are going to somebody else and you are asking, well, I want to buy, for example, a motorcycle for, let's say, 5,000 euros. But you don't have your cash money, you don't have 5,000 euros, and also on your banking account, you maybe don't have directly on your overnight banking account, also not 5,000 euros. But maybe you have another banking account with a longer maturity, let's say 3, 6 months or something like this. And you show this and say, well, within 3 months, I have this money. Can I buy this good today? And then in general, it would be possible that you can buy a good today when you are showing that you have a deposit with a longer maturity. And therefore, we define the so-called money aggregate M2. And there, in general, we are going up to deposits with maturities to roughly 2 years. And the last one is M3. And M3 is then, yeah, the general definition of modern money. And for this, you also have to keep in mind, where do we use in a modern economy very much money? This is in the financial system. Think there again about the circular flow, where all the savings and the investment was coming in and going out. So all the exchange between the banks, between insurances and so on. And there you have the so-called repurchase agreements when these financial institutions are dealing with each other, also money market funds, and of course also debt securities, again with maturities up to 2 years. Well, and if you take all this together, then we can sum all these up, and what we then see is then in the European Monetary Union, we have roughly 16.5 trillion euros right now. And yeah, then we can think of, is this much? Is this less? Why is it roughly this number? 16.5. So if nothing else is said and somebody says this is the money growth rate, or this is the amount of money which we have, then in general these aggregate M3 is meant. Well, then again we can ask ourselves, well, this money is used to buy all our goods and services. And for this, we can compare this amount of money with GDP of the European Monetary Union? Well, this of course we could look up, but maybe we can also roughly estimate this number. So what are the member states of the European Monetary Union? Who is always, in which countries you can pay with a euro? Hmm? No idea? Germany? And? Yep. A little bit louder? Yeah, most, but which one? Yes, of course. So we have here Germany, France, Spain, Italy, and so on. So, and do you know how many people are roughly living in the European Monetary Union? Or let's look it up. Okay, so people in EMU. So it was roughly 350, 40 or so, something like this, yeah? How many people live in Germany? Roughly. So let's say roughly 80. And so we can say, well, it is roughly 25% of the people in the European Monetary Union are living in Germany. And if we assume that we have a relatively even living standard in the European Union, then we can also say the number of people is highly correlated with GDP. So in general, we can assume that GDP is highly correlated to population. And then we can say Germany GDP is roughly 25% of GDP of the European Union. And then hopefully, without looking it up, what is roughly GDP in Germany right now? This I have talked a lot when we were talking about GDP. And some numbers, hopefully, you keep in mind after this lecture. A little bit more. 3? No, not 8. So it was roughly 4 trillion euros. So 4 trillion euros in Germany, roughly 1/4 of GDP in EMU, and then this translates into roughly 16 trillion euros in the European Monetary Union. Well, and then we can take the relation here with our amount of money, and then we see, well, this is a reasonable amount of money if we assume we need all the money to buy all our goods and services which we are producing within 1 year. And this is, so to speak, also roughly the idea how the central bank want to steer the amount of money. But let's see, or you can look it up, what is the right value of GDP 2023. Hopefully I'm right, of the European Monetary Union. This is per head, and European Union. Always per capita. Maybe we have it here too. Gross domestic product. But this is the EMU. European Monetary Union. European. Oh, let's then look up of the Eurozone. Maybe we find it easier. GDP Eurozone. Have you found it? I thought I would be quite faster. Sorry. These are all the growth rates. This we don't want to need. Well, I look it up and then I give you the right number, but it is roughly in this neighborhood of this 16 trillion. I think it's a little bit less, about 14 trillion. Okay. So what we have done here is somehow, yeah, just to interpret the use of money within our economy, and this concept is called the so-called quantity theory of money. This means that we say we have the total amount of money, and then of course every euro within a period we can use not only once but more often. So times the velocity of money, how often I can within a given euro using my money, equals just the total amount of the value of the goods I am buying. So just price level times real output. This is just what we were talking about when we talked about GDP, price times quantity. Well, and if we look in more detail into this equation, then we can say, okay, this velocity of money depends on the framework and infrastructure of payment methods. So if you have only cash money in history, you cannot use that often the same euro. And then you have introduced credit cards, your banking account, that you can go shopping with your banking cards. Then it is even faster. And then recently we invented digital payment methods via Apple Pay, um, PayPal, and so on, or even you can directly pay more or less within your Amazon account. So this all speeds up the velocity of money, but this, of course, these inventions take a long time. So then we are talking about time periods of 5-10 years of these innovations. So then velocity of money is changing slowly. And also, if we look at real output in developed countries, then we can also say, well, we have this aim of roughly 1 to 3%. So compared to prices, real GDP changes also slowly. Well, and then in a thought experiment again, we set more or less relatively to the total amount of money and the price level, these two numbers constant because they are only changing very slowly. Then you see, taking these equations, we have more or less a one-to-one mapping of increasing money and increasing prices. That then we would obtain these direct um, proportionality between the growth rate of money and the growth rate of prices, which is inflation. Let's take this also analytically. Then we can write, well, if we take this quantity of money as given, we can rewrite this as money equals P times Y. So this is real GDP. And then if we go to the money market, we could say, okay, this amount of money equals money demand, taking this up here, this equals P times Y times 1 over V. And 1 over V on the other way around, not the velocity of money. This we call the so-called cash holding coefficient. Then we obtain money demand equals a constant K times prices times income. And this then means that from this argumentation, when we mainly look only at the transaction motive of holding money, we obtain in the end also a money demand function, but within this money demand function, we do not find the interest rates. So in this case, we obtain a money demand function which is only depending on income. And of course, it is also positively depending on income. And this is called the so-called neoclassical money demand function when you mainly look only on the transaction motive. So this money demand function comes mainly from the transaction motive, and then we have no dependence on interest rates. Yeah, but as we had it in other aspects, we are often not interested in the absolute values of our parameters, but in economics we are very often just interested in the relative change of our variables. And for this, we can recalculate using the quantity theory of money. And if we taking the total differential of the logarithm of both sides. And this is a mathematical trick how you can very easily come from a multiplication to a sum and the growth rates. And this we just want to do together. So taking logs of both sides would mean ln of m times v equals ln times p ln of p times y. So, and then hopefully You can answer the question, how can I rewrite the logarithm of a multiplication? Log of x times y. How can I rewrite this? The log of the multiplication of two variables equals the sum of the individual logs. This maybe in class 10 or 11 you should have learned in mathematics. So then this translates in ln of m plus ln of v plus ln equals ln of p plus ln of y. And now we want to take the total differential. This is more or less the general derivative because we have here a multi-dimensional function. We have four variables. And so to speak, we want to derive simultaneously this equation with respect to all four parameters. And therefore, we have to know the first derivative of the function f of x is log of x. What is then the first derivative? In economics, you don't need very much functions. So it is x squared, it is square root of x, exponential function, logarithm, 1 over x maybe, but that is more or less is it in economics. What is the first derivative of log of x? This is 1 over x. This you also should have learned, and all of you have participated in introductory of mathematics. Hopefully you have also talked about the derivatives of simple functions, or? Okay, so if we take with respect to money, then we have 1 over m. Taking the total differential means then that we have to multiply this also with the change of our variable. So 1 over m times delta m plus 1 over v times delta v equals 1 over p delta p plus 1 over y delta y. And the nice thing is if we make these calculations, we directly can translate our multiplication, our quantity theory of money, where the parameters are multiplied with each other, that this translates into the sum of the growth rates, because this is nothing else than the growth rate of money, growth rate of velocity in time, but there we assume this changes only very slowly. So this is then roughly zero. This is inflation. And this would be GDP growth, which we assume is compared is changing compared to the other variables also slowly, and then we again find that more or less the growth rate of money equals the growth rate of inflation. Not the growth rate of inflation, equals inflation itself. And from this dependence, we then could say if we try to boost the economy by just printing money, we should not be surprised when the result is then more or less only a change in prices so that we obtain high inflation rates. And from this, we have also the very famous statement of Milton Friedman, one of the first Nobel laureates, because the Nobel Prize in Economics was introduced, I think, in 1969. And he, really relied on this quantity theory of money, and therefore he made this statement that inflation is always and everywhere a monetary phenomenon. He argued that the main cause for inflation is a change in monetary growth. And if we really assume that this theory holds, then we come to the so-called classical dichotomy that we have a split between real variables and nominal variables. Where we can say, when we compared nominal GDP and real GDP, that these are the variables which really matter for us. So how much we produced in quantity. Real wage, so we are not very happy just because we have a 10,000 euros wage per month or so, but how much can I buy with my 10,000 euros? So I have to divide my 10,000 euro again by the price level. Today we have talked also about the real interest rate. While compared to this, on the other hand, we have all our nominal variables, and these are all valued in a currency. Here I took just the anchor in the world, US dollar. And if we then say this quantity theory of money holds, then it more or less doesn't matter what kind of number is printed, for example, on our cash money. And there is a very famous thought experiment by Adam Smith. Maybe you know him from school, the inquiry in the theory of wealth of nations. So maybe one of the first classical economists in the 18th century. And he made the thought experiment, well, what would happen in the United Kingdom when we just change overnight the color of pennies from red to green, and we inform everybody that now the green pennies have twice the value of the red pennies. So in modern terms, we just would say we double every banking account overnight. And then the thought experiment, what would happen? Well, are we then really happier? Everybody has twice the amount of money compared to yesterday. But if we then think of the economy, since everybody knows this, that the amount of money has just increased by 100% overnight, then in every supermarket, in every bakery, in every shop, we would say, well, the enterprises also just double their prices because they know everybody has twice as much money as yesterday compared to yesterday. And this is just what this quantity theory of money says. When we are increasing our money, this translates just in a one-to-one increase of prices. So if nominal variables change, this has no direct impact on real variables. And here we are then at the point where we find the different views on the economy. And the classical economists, they just say, well, only printing money, only having a higher nominal value at my banking account doesn't matter for the economy in real terms. And then there is the other view, and these are called Keynesianists, coming from also a famous economist in the beginning of the 20th century, John Maynard Keynes, and he said, well, I understand your argumentation, but in general, the economic agents, they behave myopic, so that they are in general look only in the short term. So if we just see that we have a higher number in our banking account, or if the government gives everybody 100 euro, then we do not really calculate, well, everybody has done this and therefore just only prices will rise. We just start to buy goods and services. So he argued that there are frictions in the market, that the prices cannot really directly adjust as here in the argumentation of the classical economists. And this is then, yeah, more or less for economic policy, the great question, which framework just applies in the actual times. Is it possible to push money if I just start to spend money as a government, or is it not possible? And yeah, we are almost done for today. So this is also a good end, because this was more or less the controversy within the coalition in Germany. That the one side said, well, we have to spend money in the public sector to push the economy. And the other part of the coalition said, well, but we don't have the money directly in Germany. Therefore, we have to increase our debt, our public debt. And this would mean more or less we are printing money. We giving money into the system. And then the argumentation is, well, this will not help, because in the end, this pushes only prices, and then we are failing the aim of price level stability. Okay, then we are done for today. Oh, yeah, and this effect that, so to speak, money is only in between our exchange system between goods and services, in the end, we are exchanging real goods and real services, and money is only the medium of exchange in between, then we are talking about this as the so-called neutrality of money. And that in the long run, money is nothing than a whale within our economy. Yeah, and then next week we will come to monetary policy and central banks. Thank you very much for today.